The mirror modifier allows us to significantly reduce our workload for any object that has at least one line of symmetry by mirroring changes made on one side of an axis over to another. In order to access the mirror modifier, come to the Modifiers tab in the Properties panel. It should look like a tool wrench icon. Left click where it says Add Modifier, go to Generate and come down to where it says Mirror and left click. This will add the mirror modifier to your model. If we want to correctly set up our object for using the mirror modifier, we have to effectively delete one side of our model. Here we just have a default cube, and by itself we're not going to be able to correctly divide this in half without adding new geometry. To do that, I'm going to add a loop cut, and we'll add the loop cut here along the x-axis. And because we've got that loop right in the center of our model, we should be able to delete one half of the model. Now I'm going to go into my wireframe viewport shading. I'm going to make sure this X-ray option is active. I'm going to deselect everything, and then I'm going to select these vertices here, press the X key, and choose to delete the vertices. In this example, we've been able to delete one half of our cube on one side of the Y axis. Now I'm going to return to solid view and make sure that the X-ray option is turned off. And this sets us up for using the mirror modifier. So return to the Modifiers tab in the Properties panel, add modifier, select Generate, and then choose Mirror. If it doesn't work initially, then all you may need to do is change the axis. Here I'm going to change from X to Y. And now we have mirrored our geometry from one side to the other, but make sure you turn off any other axes that you don't need. The mirror modifier is most similar to the mirror tool, but there are a couple of key differences. Here I've got another instance of our cube that I have once again cut in half and deleted along the Y axis. Keep in mind this is different to the cube in which we added the mirror modifier to. And for this object, you can mirror it over to the other side by going Object, then Mirror. You can then define your axes and whether or not you want to use global or local orientation. The key difference here is that when you choose one of these options, it's simply going to flip your existing geometry over that specific axis using the object origin as the reference point. You can change how this works in the operator panel, so you can define either the X, Y, or Z values, as well as the specific orientation that you want to use. However, as you can see, the default functionality of the mirror tool only flips the existing geometry over to the other side of a specific axis. It does not duplicate the geometry and flip it over to the other axis, which is what the modifier does, and this allows us to edit both sides of our axes using the line of symmetry. So compared with the mirror tool, what is the main benefit of using the mirror modifier? Well, aside from the fact that you can edit in real time the different parameters, you can also edit the geometry over on both sides of a specific axis or line of symmetry. Let me show you what I mean by that by going into edit mode. I can select any of the geometry on one side of the Y axis. For example, I can select this edge right here. I can then manipulate this edge however I want, but watch what happens to the mirrored edge on the other side of the model. I'm going to hit G, then Y. As I move this inwards, you'll see that the adjacent edge on the other side of the cube is actually mirroring the effect that is being applied to the selection. So I can move this in, left click to confirm, and I've effectively halved my workload there. All it was grabbing and moving a single edge, but it allowed me the ability to move the opposite edge in the same manner. This also applies to just about any tool, such as extrusions or loop cuts. For example, I can create a loop cut right here, and then I can go in to my face select a face, and hit the E key to extrude, and you'll see that it all perfectly mirrors on the other side of the y-axis. So this way, I can effectively use any tool that I want, and then it will mirror the effects of that tool over on the opposite side of the model. If you were to apply the mirror modifier, any geometry that would have initially been the mirror of your existing model will become its own geometry. So at the moment, when we have the mirror modifier active, we can only edit one side of this object, but it will in turn mimic those changes over to the other side of the defined axis, which in this case is the y-axis. But there may come a time when we want to start differentiating the details that we have on either side. It is at this point that we would apply the mirror modifier. So I'm going to go into object mode, click on this icon here to bring up the menu, and then select apply at the very top, and this will apply the mirror modifier to the cube object. Now if I hit tab, you can see that we are able to select geometry on both sides of the y-axis, and we can begin to create unique details on each side of our model. The mirror modifier can be used in combination with other modifiers. So for this example, I'm actually going to use Ctrl-Z a few times until we can get the mirror modifier back. And if we go into edit mode, we can confirm this as we begin to again manipulate our existing geometry. Now here, I want to combine this with another modifier, and I can do this with many of the different modifiers in Blender. For example, we could add a subdivision surface modifier. So I can left click to add the model and increase the number of viewport levels. And what this will do is it will take not only the existing geometry created with the mirror modifier, but it will also take the geometry created after the fact along that line of symmetry, in this case the y-axis. If I swap the positions of these two modifiers, we actually get a slightly different effect, and the change you should see is going to be at the center of the model. So keep in mind that when we put subdivision surface below, it's going to subdivide the entire mesh as a whole, which means it's also going to smooth out the intersection from the positive y and negative y axes. However, if we place subdivision surface above the mirror modifier, it's going to subdivide one half of the geometry, and then the mirror modifier is going to take that geometry and mirror it over to the other side of the defined axis. This is why, when the mirror modifier is below subdivision surface, you may see a sharp line that divides the two halves of your model. And this is something to keep an eye on when you're creating things like character models, for example. If you have the mirror modifier after other modifiers like subdivision surface, then you are going to be quite likely to see this sharp line that goes down the middle. Next, let's replace subdivision surface with another modifier. This time, let's try wireframe. So with the wireframe modifier, we create a wired version of the existing mesh. Here, again, we've got wireframe under the mirror modifier. So the geometry is first mirrored along the y-axis, and then it is converted into a wireframe. If we were to click and drag and replace the wireframe with the mirror modifier, this time we don't actually see a visible difference. And this is an example where the mirror modifier does not actually affect too many other modifiers in Blender. It all depends on which one you choose in combination with the mirror modifier. So this is an example where we can safely use something like the wireframe modifier and place it either above or below the mirror modifier. Let's take a look at some of the parameters of the mirror modifier. And here I've got a cube that I'm just going to delete most of the geometry from. So I'm going to go into wireframe mode, front orthographic view, and I'm going to select all of this geometry, hold shift, select all of this geometry, press the X key and delete it. Then I'm going to rotate my view, select this geometry and delete it as well. So I'm basically left with one corner of my cube. Now I'm going to go add, generate and select mirror to add the mirror modifier to our cube object. First of all, you can define the axes on which you want to mirror your geometry. We can turn this off just by left clicking, and this gives us the default geometry that we have without the mirror modifier applying any effect to the model. If we press this X icon here, we're going to mirror the geometry over on the other side of the X axis. If we turn this off and turn on the Y parameter, we're going to mirror the geometry over on the Y axis. If I turn on the Z option, we're going to mirror on the Z axis. In addition, you can also enable multiple axes at the same time. So currently we have it set to Z, but we can also enable the Y axis. We could enable C and X. We could enable X and Y. And we can even enable all three of our axes. So in this case, we have restored our cube by using the mirror modifier. Because we have mirrored the geometry on 3 axes, it's going to mirror any changes we make to our model on each of these axes at the same time. So if I go into edit mode, for example, let's select all 3 of these faces and then press the I key to inset. We've created some new geometry, and now I'm going to extrude this geometry. So I'm going to choose the extrude individual option or extrude along normals, and we're going to click and drag to create the new geometry. And here you can see this one tool has been replicated across the entire cube. I actually think there are going to be 8 instances in this example. So each time we enable an axis, we double the number of times a tool is going to be affecting the model. In this case, we've used one extrusion and we've been able to extrude our geometry 8 times across the object. You can see what I mean if we go into object mode with the new geometry. The axes in question that we are referring to when we are manipulating these values relates to the object origin. So, what would happen if I was to move the object's origin in Blender? I can go to the options menu and select origins. I can then use the grab tool and begin to move my object's origin across on one of the 3 axes, in this case the Y axis. Then I'll go back to options and turn off the setting for origins. If we take a look at the transform values for our objects, you can see we've actually moved this along the Y axis. But how does this affect the mirror modifier? Well, first of all, let's see what happens if we try to mirror on the X. This appears to be functioning as we would expect it, but what about the Z? Again, it appears to be functioning correctly. But what about the y-axis? Now we see a difference. It's taken into account the location of the geometry in relation to where the object origin is. So the object origin has a local coordinate system of 0, 0, 0, no matter where it is. And that's what the mirror modifier uses. It uses the local coordinate system of the model, not the global coordinate system of the 3D viewport. Because of this, if you move your geometry away from your object origin and then attempt to mirror that geometry on a specific axis, then you'll find that the mirror geometry is of a similar distance from the object's origin point. In this next example, we're going to be taking a look at the bisect parameter. So here I've made two changes to this default cube on the x-axis. We've made one change on this side where we've brought the geometry up on the z-axis, and on the other side we've moved it across on the x-axis. So this object is no longer symmetrical on either side of the x-axis. If I was to enable the axis mirror by left clicking, what would happen is we would mirror the changes made on both sides over to the other side of our model. This may not be the effect that we're looking for, or perhaps it is. But what we can do instead is use the bisect option. So if I left click here, nothing happens initially, but if I left click on the axis option as well, the geometry that was moved along the x-axis initially is now being moved along the z. So what we had before has in fact been replaced by the geometry on the other side of the object. Now the way this works is that the bisect tool is only used when we have geometry on both sides. So before, when we was using another cube, we only had geometry on one side of each axis, and we would choose the appropriate axis option to mirror that geometry over to the other side based on the object origin's location. However, in this example, we had geometry on both sides of our 3D model. So in this case, if I turn off the bisect and axes, you can see that we have geometry that exists on both the positive side of the x-axis, which is defined by the red line, and the negative side as well. When we enable the axis, it of course mirrors over on that specific axis, but when we use bisect, what it does is it cuts the mesh across the mirror plane, which is coordinate 0, 0, 0 in this case, where we go from the positive x-axis to the negative x-axis. Effectively, what we're going to do here is we're going to be mirroring what is on the positive side over to the negative side. And that will replace any geometry that exists on the negative side of the x-axis with the mirror geometry from the positive side. And below the bisect option, we have the flip option. In this example, we can go from the positive x direction to the negative x direction by selecting this option right here. That's going to mirror what was on the negative x side of the object over to the positive side. So to summarize, when we only use the x-axis for this example, we mirror the geometry from each side over to the other, which effectively adds to the geometry, but can also create complications in the model as well. When we enable the bisect option, we're taking the geometry from the positive side of that axis, and we are mirroring it over to the negative side of the axis, replacing any geometry that was before. And with the flip option, we take the geometry on the negative side first and mirror that over to the positive side, replacing the geometry that was on the positive side of that axis beforehand. Up next, we have the mirror object, which replaces our object's origin point as the key point of reference for defining the axes and the positive and negative direction of each axis with an entirely separate model. So I'm just going to hide this object and replace it with a new cube. And you'll notice that I have started to name some of these examples. This is just for organizational purposes, but I'm going to name this one as mirror object. And we're going to add the modifier again, which is going to be the mirror modifier. This time though, I'm going to add a second model. And for this example, I'm going to use a plain axis empty. Now you won't be able to see it initially because it's in the same location, but if I press the G key and move it about, you should see the empty object. I'm going to right click to cancel the motion, then select the cube object, come to where it says mirror object in the mirror modifier, and from this list I'm going to select empty. Nothing happens initially because the object itself is in the same location as the empty. But if I press the G key and begin to move my cube, you will see that the change in location is mirrored on the x-axis. So I can move on the positive x and it will create a duplicate of my geometry on the negative x-axis. So I can position, left click, and now I've effectively used the mirror modifier to create new geometry, but at the same time, I have been able to also move the object's origin. Beforehand, it was simply a case of going into edit mode and manipulating the geometry and then using the mirror modifier to mirror it over a specific axis. But now we're able to take the entire model and mirror it over a specific axis using a separate object. We can change this to the Y axis if we require, or even add to, and even use the Z axis. So here I just grab and move my geometry up, and you can see we've actually created 8 cubes where there was once a single cube, and we've been able to achieve that using the mirror modifier. So this can be almost like a replacement for the array modifier or the duplicate tool if you want to position your duplicates in a specific location using a currently existing object. Clipping can occur when we have geometry on the wrong side of our object origin, and as a result of this, that geometry is mirrored incorrectly on both sides. Here we have 1/2 of Suzanne, and I'm going to add the mirror modifier. This all operates correctly because we have accurately deleted 1/2 of the model, and we are using the mirror modifier to mirror the geometry from the positive x over to the negative x axis. However, now I'm going to hit the tab key to go into edit mode, and I'm going to press A to select everything and press G to grab. Now I can move my geometry away from the center, but I can also overlap it. And if I do this, you will see that the mirror geometry also overlaps. So let's say I move it along the x-axis and we move it to about here. Then we go back into object mode and we can see that the issue that we have down the center of our mesh where the geometry overlaps over to the other axis. The easiest way to fix this issue is to use clipping. So I can enable clipping here, and by default it's not going to fix the issue, but if we hit the tab key again, then hit the G key, lock to X and move it apart, you'll see that we begin to actually stretch the geometry, because as soon as they get close enough, these vertices are going to merge together and we're going to be able to better control that geometry as it prevents it from overlapping while clipping is enabled. So again, if I press G, I can move it in any direction now, either inwards or outwards, but it will always stay where it should be in the center. Merging will allow us to literally stick our geometry together depending on the defined distance, and this is normally used in combination with the clipping option. Now, if I was to click and drag to increase the merge value, eventually on our model you would begin to see vertices starting to join together, particularly here in the nose and mouth. The further we increase the value for the merge, the more geometry is going to be combined and connected. So we have to be careful not to go too far with the merge value. One way that we could perhaps use this if we turned off clipping is we could hit G and X to create some distance and then increase this value until the geometry that is within that distance snaps and merges together. And we can even do that without the clipping option being enabled. Again, you would ideally want to combine merging and clipping together so that you can clip and merge the vertices at the center. But keep in mind that as you increase that merge value, eventually you're going to start to join together vertices that are much further away from that line of symmetry, which is typically going to be your object origin or another object if you're using the mirror object parameter. So for us, I'm going to turn both options off for now. Hit G, then X to bring them as close together as possible. Then enable clipping, merging, and just bring that value down as low as you can so that it all merges together exactly how you want it to. The bisect distance parameter will only function when the bisect parameter is being used. So we're back here with the bisect example that we looked at earlier on in the video. With bisect distance, it effectively determines the distance from the bisect plane within which the vertices are going to be removed. Now the bisect plane is obviously going to be whichever values you have here selected. So in this case, we're working with the x-axis. If I was to increase this value for the bisect distance, eventually it would reach a point where the geometry that the bisect option had actually removed would then reappear. So if I click and drag and bring this value high enough, which will probably be about 1 meter, you'll see that the geometry reappears on our model on both sides. This is the geometry that was originally on one axis, but was removed because we used bisect to mirror the geometry from the other side. But now, with the bisect distance set high enough, any vertices within 1 meter of the object origin in this case will be maintained on both sides. Perhaps a better way to show this is if I create another change on one side of the model. So let's just disable the mirror modifier for the moment. And then let's pop into edit mode and we're just going to make a subtle change to our geometry on one side. So all I'm going to do is I'm just going to create some additional geometry here. Go back into object mode and then restore the visibility of the mirror modifier, which had been hidden. So here we've got a bisect distance that is set to 1 meter, so everything's currently showing. But you can see here, as I reduce this value, you can see how some of the geometry that I had just generated is now reappearing along the line of symmetry. So this is something to keep in mind depending on the positioning of the geometry that you create when using a tool like Bisect Distance. Let's just pop over a few troubleshooting tips when using the Mirror Modifier. The first troubleshooting tip, and many of these tips may gloss over what we've previously covered, is that the object origin defines the center point for any mirrored axis. So if you find that you use the mirror modifier and you can see that it's not actually working, then it's probably because you've got your object origin right at the center of your model's geometry. However, if you were to move your object origin, for example, say press the G key, you would be able to change the object origin's position, and therefore the geometry would begin to mirror along the other side of that specific axis. Alternatively, you can go into edit mode, hit G to select your geometry, and then move it apart on the given axis. In this case, the x-axis, I can click and drag, left click to confirm, and again, I've created a mirror on both sides. So I can do this by either moving the object origin or by moving the actual geometry in edit mode. Another issue you may come across involves when clipping is used and the geometry overlaps but does not merge correctly. I can demonstrate this by adding another modifier, but before I do so, I'm going to just hit Alt and G, and actually let's just replace this with a new cube, fresh from scratch. Make sure that we are not affecting the object origins by themselves, and then we're going to add our mirror modifier first of all, and then we're going to follow that up with subdivision surface. Now I'm going to go into edit mode, hit G, then X to move across. And you can see here we've got two cubes that have been subdivided. I'm just going to increase the count for the subdivision surface modifier. And now I'm going to enable clipping. Watch what happens if I hit the G key and bring the two objects closer together. You can see that they begin to snap into place, but there is an issue here. That issue is the fact that even though it looks like it's working correctly, there is in fact an additional face created at the center, and this can create key issues when shading. So if I shade smooth, for example, you can actually see in the center the shading artifact that occurs because we actually have overlapping geometry here. That overlapping geometry is this face. So this face is being mirrored over to the opposite axes, the same as all of the other faces on our model. The best thing for it then is to remove this face so that we can remove the artifact that is formed. Press X and delete that face, and as soon as we do that, you will see a much smoother shade on our geometry, even when using clipping with the mirror modifier. Another issue that may occur is as a result of the modifier stack. So sometimes you may get an effect that you weren't quite expecting, and the solution may simply be changing the order of your modifiers. So here we have subdivision surface and mirror. Now looking at this, if we were to change the order, we wouldn't really see any visual change. The only noticeable change at the moment is actually in the side panel, where the overall dimensions of the object seem to change, even though there's no visual difference. However, let's now go into edit mode for the object, and I'm just going to change the location of this face on the X and Z axes. So I'll bring it down to about here, and then come back to object mode. Now, it might be difficult to see, but we're getting some stretching along the intersection between the original geometry and the mirrored geometry. So this is affecting the shading of the model in this area. This is because we are subdividing first and then mirroring second. But ideally, we're going to want to mirror the geometry first. so that subdivision surface can use the geometry on both axes to create the correct shape. You can also see if we zoom out, it's a very sharp effect at this location, which you may not want. So all you may need to do here is just click and drag to put the mirror modifier above subdivision surface. This completely changes the result, eliminates any of the artifacting or pinching at the intersection, and creates a smoother curve with the geometry because it's mirrored the geometry first and subdivided it second. One area of the mirror modifier that you may not even notice is the data section at the bottom. Now within this data section we have a couple more abstract settings that we can use with the mirror modifier. Primarily these will help us to better manipulate the UV coordinates for our models. This means that we can use the mirror modifier to control how textures are applied over our specified axes points. To best demonstrate how these options, mirror UV and offset UV, are going to affect our model, I have for this example created a texture map for Suzanne. If we go into material preview, we can see that we have applied a texture map to our object. Now by default, it actually already mirrors the texture from one side to the other. And this is without changing any of the settings here in the data section. If you need a refresher on what the term UV means, it effectively represents the 2D coordinate system that is used to map an image texture to a 3D model. If we go to the UV editing workspace and we are in edit mode for the model, we can press the A key to select all of our geometry and we would see that geometry appear on our UV map. So everything you see on the UV map is going to be projected onto that geometry for your 3D object. If we were to take a look at the shading workspace, we would see that we have a very simple setup where we have a wood texture that has been applied to the principled BSDF shader to create the texture and material on our model. Now again, if we take a look at our object, you can see that the UVs have been mirrored over to the other side of our object. So we basically get the same texture over the associated line of symmetry. But we can change this appearance by using both the mirror UV options and the offset UV options. The first option is to mirror the UVs. So if we were to hover over the tooltip, it would tell us that this represents the amount to offset the mirrored UV's flipping point from the 0.5 coordinate on the U axis and then on the V. Now if I was to enable even the U option, watch what happens to the texture on one side of the object. It immediately changes. Now if I was to select the second option to mirror the V axis, it would change again. So what's happening here? Well, if we take a look at the UV editing workspace, imagine that we have two axes. U goes across to the left and V goes up. This effectively replaces X and Y because in 3D space, we typically refer to X, Y, and Z as the three 3D coordinates. So to make things simpler, instead of using X and Y for 2D maps, U and V are used instead. Now, back to the Mirror U and Mirror V tools. When set to on, for example, with the Mirror U parameter, we're taking 0.5 on the U axis and we are flipping the texture at that point when this is enabled. We can then offset this value, so where along the U axis we're going to flip the texture by clicking and dragging in either the positive or negative direction. So if I was to just zoom in on our model, and then we're going to transition into our material preview, you can see as I click and drag, in either direction, how we are just offsetting where the texture is being flipped to. So with a value of 0, it's around here for the U, and around here for the V, where it's being flipped over from one side to the other. So we can enable both of these if we wanted to, but to keep things simple, let's just enable one. And if we were to navigate to one side, so a positive value, I believe that pushes the coordinates closer towards 1 in the UV system. So it would move that flipping point closer to this side. And then if we use a negative value, it would move it closer to 0 using the UV coordinate system again. Then below that, we have the ability to offset the UV coordinates. So this represents the mirrored UV offset on each axis. And this is a simpler way to think about it than the mirror UV. So the mirror UV option finds a certain point on either the U or V axes and then flips the texture at that point. But the U and V offset parameters simply take the generated geometry and move or reposition the generated geometry on the texture map. So again, if we were to manipulate the U offset, we would again be able to manipulate the texture positioning as well as the V offset. And you can actually see, if you take a close look at the grain, the direction in which the grain travels from left to right with the U offset, and also up and down using the V offset. The next option allows us to mirror vertex groups. Now this is different of course to UVs, which relate to texture coordinates. So what we're going to do here is we're going to create a couple of vertex groups for our Suzanne mesh here. We can do that by going to the Data tab in the Properties panel, moving into Edit mode, and let's just select, first of all, the eye, and create a vertex group here. Double left click, and we're just going to call this eye, but this is the important bit. We have to name it so that Blender knows that it's either the left or right version of that vertex group. So here we're going to name this vertex group as I.L. So the suffix here, .l, is used to indicate that this is going to be the left version of the I vertex group. We're then going to select Assign. Next, we're going to deselect everything, create a second vertex group, and rename it as I.R. We're going to not assign anything to this vertex group, but we are going to choose the select option just to make sure that nothing is selected on our model when we have I.R. And if we go to I.L and press select, all of the geometry for the I.L vertex group is going to be selected. Now what this will do is when we apply the mirror modifier, it's going to assign the mirrored version of one vertex group to the other. So let's take a look at this in effect by going to the Modifiers tab. Ensure that Vertex Groups is ticked underneath Data, and if you're not sure, just untick and tick again. Then go and apply the Mirror Modifier. Now press the Tab key and you'll see all of the new geometry that has been created. We're going to go to our Data tab, and first of all, let's select I.L, which chooses one eye, deselect that, then choose I.R, press select, and it will select the opposite eye that was created using the mirror modifier. That wraps things up on the mirror modifier. Don't forget to like, subscribe, and click the notifications icon for updates on future videos relating to Blender and its many tools in the realm of 3D modeling. So I'll see you next time.